full-body motion capture has been used in film, interactive games, and other immersive experiences. These systems all require special sensors, either worn or external, in order to capture a user's body. This limits mobile use, and the additional hardware and cost reduce feasibility and consumer appeal. We present Pose on the Go, a full-body, motion capture system that uses sensors already found in today's smartphones, thus requiring no extra or external hardware. To achieve this, we pursue an extreme sensor fusion approach. Using the front-facing camera, we can capture the relative spatial position between the head and hand holding the phone. As we do not have data for joints, such as the wrist, elbow, and shoulder, we use inverse kinematics to estimate and animate probable body poses. Simultaneously, the IMU and rear-facing camera of the phone provides a gravity vector, which allows us to orient the phone and hand, as well as the head, with respect to the world. The hand that is not holding the phone generally cannot be seen or tracked, except when the user touches the screen, which then allows us to estimate the finger and arm position. By using the phone's front-facing depth camera, we can compute a chest normal, which allows us to orient a user's torso independently from the head. We can also animate the legs, despite having no direct sensor data below the torso. First, we use the phone's locomotion mode prediction to load the appropriate kinematic scheme, such as standing, running, or walking. Then, by using the IMU to integrate absolute body movement, we coarsely animate the avatar's legs at the appropriate speed. Finally, using the phone's rear camera and visual odometry software, we can estimate the elevation of the phone with respect to the ground plane, which, in turn, gives us the elevation of the user's arm and head. We feed this height data to the inverse kinematic solver, which allows our pose model to stand, step onto objects, and sit down. We performed a series of studies, benchmarking our approach against a professional-grade optical tracking system. Although Pose on the Go is unsurprisingly less spatially accurate, the estimated pose is more than sufficient to power a wide variety of new and interesting applications. For example, it could enable new full-body, mobile gaming experiences, such as spellcasting in this fantasy game. In this third-person shooter, the phone is a laser used to aim and shoot, and users can freely walk around and duck behind cover. Pose on the Go could also be valuable for health and wellness applications. For instance, phones could automatically count exercise repetitions and track performance quality. In this demo app, reaching exercises could be part of a physical therapy rehabilitation regimen. In this mobile AR teleconferencing app, one can handshake and perform other full-body gestures, enhancing social communication. Similarly, today's face-centric Animoji could be extended to full-body animations, allowing for more expressive communication. Please see our paper for full details.